Good morning to everyone. Myself is Devi, Assistant Professor, Department of Artificial Intelligence and Data Science. I am going to teach the subject structures using C++. Today we are going to discuss about the topic searching. Searching is the process of finding the position of a specific element in a list, array or data structure. Searching is very important because in many applications we need to locate the data quickly. There are two different searching techniques, linear search and binary search. Linear search is otherwise known as sequential search. Sequential starts at the beginning of the list and checks every element of the list. Elements are searched one by one from the beginning. It works in the unsorted array. It is very simple and easy to implement. It is basic and simple searching algorithm. In sequential search, comparison takes place of all the elements given in the list. If the element is matched, it will return the value of the index, else it will return -1. It is one of the easiest approach in searching. Consider an array, set of elements, n number of elements, and we are considering x as the element that is we are going to search. We have to search the element one by one starting from the first index. If the element is found, it will return the position of it, or otherwise it will return -1. Consider the example. The array consists of 8 elements. We know that the array starting index of the array is 0, so it ranges from 0 to 7. The element we are going to search is 12. So we have to search the first element of the array, that is 65 is compared with 12. It is not equal to, that is 65 is not equal to 12. So the searching takes place to the next element, that is the element present in the index 1. Next it will compare with 20. Here the 20 is also not equal to 12. So what happens? The searching takes place in the next element which is present in the index value 2. Next 10 is compared with 12 and it is also not equal to 12. Then the element we are searching. So the searching takes place to the next element, that is 55, which is present in the index value 3. So 55 is not equal to 12. So next it searched for the next element 32, which is present in the element 4. Here also 32 is not equal to 12. So the searching takes place to the next index, fifth index, that is 12. Here the searching element is equal to the element that is present in the index 5. So it will return the index 5. Advantages: it is simple to understand and easy to implement. It is works under the unsorted array. It no need for extra memory. Disadvantages: it is slow for large array, that is if it contains a number of elements, n number of elements larger and n value of n, so it will take more time. The application is searching element in a small data set, searching in unsorted list or array, finding a record in a sequential file. This is binary search. Binary search works on the sorted array. It repeats the divided the array into half to locate the element. Searching a sorted array by dividing the search interval in half, being with an interval covering the whole array. If the value of the searching key is less than the item in the middle of the interval, narrow the interval to the low half, otherwise narrow it to the upper half. So consider an example. An array consists of 10 elements. It ranges from 0 to 9. The element we are going to search is 23. In the case of binary search tree, we have to find the low value, high value and the mid value. Low value is nothing but the first index of the first index of the array, and the high value is nothing but the last index of the array. The mid is calculated based upon the low value plus high value divided by 2. So here in the case of L equal to 0, h equal to 9, and the mid is calculated as 0 plus 9 divided by 2, which is equal to 4. The element in the index 4 is 16, where 23, the element we are searching is 23, is greater than 16. So the searching takes place in the second half of the array. So the L value changes to mid plus 1, that is the L value is mid value is 4. So 4 plus 1, it is 5. Now the value of L is 5 and h is 9. Now we are going to calculate the value of mid, that is 5 plus 9 divided by 2, which is equal to 7. So we will search the element the present in 7th index. Present in the 7th index is 56. When comparing to 23, it is greater. So the searching should take place in the first half of the array. So the high value will be changed. Now the value of high equal to mid minus 1. Mid equal to 7. Now the h equal to mid minus 1, which is equal to 6.
Now L equal to 5, H equal to 6 is calculated by 5 plus 6 divided by 2, which is equal to 5. So the element at the index 5 is 23, but the element we are searching is also 23. So 23 is equal to 23, the element found at the index 5. This is known as binary search tree. Algorithm is, it will compare the x with the middle of the element. If the x matches with the middle element, we return to the middle index. Also, if it is greater than the middle element, the x can be searched only in the right half of the array, or otherwise it will search in the first half of. Searching takes place recursively, and the advantage is it is very fast, and it is so only large database. Disadvantages, it works only on the sorted array, and the application is searching element in sorted array or list. It find data in large database with sorted records. Searching in dictionaries and found directories are some of the applications. So this is all about sequential search and binary search. We will discuss about the next topic in the next section. Thank you.